Hey guys, BuildZoid here, and today we're going to be taking a look at the new OX129 microcode with the F7F BIOS for the Gigabyte Z790 Aorus Master X. Now, for the sake of doing like a before and after comparison, I'm on the F7E BIOS, which uses the 125 microcode. And if you're not aware, the 129 microcode is supposed to do the following. Update microcode OX129 to address sporadic vCore elevation behavior announced by Intel. So basically, there's a bug in Intel's voltage regulator, it's not really the voltage regulator that's the issue. There's a bug in the way Intel sends vid requests. Well, it's not the sending itself. The way Intel generates vid requests is bad. Because in certain scenarios, the CPU can send vid requests that are really, really dumb, like 1.6 volts. So, anyway, the new microcode is supposed to fix that. And that's what we're going to take a look at. But first, we're going to take a look at what it looks like when the microcode isn't like fixed and does send dumb voltage requests. So the easiest way I've found to do this is just Cinebench R15. It happens at the start of the test. It happens towards the end of the test. As you can see on the oscilloscope, we already managed to catch a spike of 1.597 volts. And that usually happens towards the end of the test. This isn't even the highest one. I've seen one that was like, up to like 1.6 something. Like 1.61 is about as high as I've seen it get. Now these are definitely like bad vid requests, and the reason I say these are definitely bad vid requests is if you look at, so right now we're just at idle. Let's try catch one of the, I want a short one. Man. Okay, there, well, no, that's not really that short, is it? That's still over 200 microseconds. Because technically Intel can update the, or at least as far as I can tell, they can update the voltage on like a 100 microsecond time scale. So let's try catch some spikes. Oh, there's one. That's 1.583. I set the trigger at 1.59, like worried that it won't catch anything, and we managed to get that already. And the thing is, like, it just it just goes up. And the reason this happens is that Intel has they're trying to predict VDROOP before it happens. Now the problem with this whole idea of predicting VDROOP before it happens is that if you predict VDROOP and then it doesn't happen, you get a bunch of extra voltage, which is what we're seeing right here. Though that was not exactly, I was hoping to get one towards the end of the test, which this is not. This is right at the start. Okay, let's move the trigger even higher. I'm not sure. Like, the thing is, I want to, I don't want to have the trigger so high that it doesn't catch anything. There we go. Yeah, so that's, oh, that works perfectly. So you can very, very, like, that's just, this is perfect. That's exactly what I was hoping for, right? Like, this is a vid request. This isn't, like, if this was a transient, the waveform we would be looking at, let me just, please tell me it's going to pull up. Yes, okay, it pulled up the right tab. So if this was a transient, just a regular, like, load release transient, we would be looking at something that looks more like this, where it just shoots up as the output current drops, and then it recovers. We're not seeing a recovery. Mind you, this graph is at 50 microseconds per division. What I have on the oscilloscope right now is at 1 millisecond per division. So, yeah, this is just a bad vid request, right? It's not super, it's not super high, but we're over 1.5 volts. Admittedly, we're also measuring at the back of the CPU socket, so this isn't the most accurate measurement method. Yeah. Like, we get, well, like, there is some load release mixed into this. I think, actually, is there? Because, like, what's this over here? But yeah, like we just have like a vid request that's over 1.56 volts anyway, right? Like this is 1.56. I can't imagine that there's a whole lot of load over here. Because if there was, like, here's the thing: if you have a 14900K and it's actually doing something, it put at 1.56 volts, it would pull so much power that it's like it's just insane how much power it would pull. Like this is like like for an all-core load, this is like LN2 voltage territory. So it can't be doing much right here. But anyway, let's try capture a few more, I guess. Though, let's see. I'm gonna set the trigger a little bit higher. See if I get lucky. Okay, we didn't get anything at the start, which good. Oh, yeah. The CPU is just. I mean, wait. What did we catch right at the? Yeah, the power management is just a bit dumb. This isn't even the worst thing, I think. I'm guessing we caught this right here. So there is some transient mixed into it, because yeah, this is quite spiky, but also like the vid request itself is insanely high. Like, yeah, like this block right here is like, what is that? It's like 1, 2. I mean, I guess I could just try pull up the cursors. Huh? So that's at 1.589 volts, as you can see. AY 1589. So yeah, that right there. And now, like, no, it can't be like if it was pulling like if the motherboard is outputting this much voltage, and by like somehow the CPU is pulling a lot of current at the same time, that's worse. Okay. That's way worse. If there is significant current draw happening right here, the reason I bring that up is because the oscilloscope is hooked up to the back of the CPU socket. So we have a bit of an issue in that I'm measuring the voltage before the voltage drop that happens across the CPU socket itself, right? Because the CPU socket has a non-zero resistance. The CPU substrate itself has a non-zero resistance. So the voltage I'm measuring on the motherboard with my oscilloscope gets higher the more current draw there is, right? But if there is significant current draw and we're measuring 1.59 volts on the back of the board, like, how is the like? I'm surprised that the CPU is still functional, because the like with this kind of voltage, the temperatures would be absolutely insane if there was significant load on the CPU. So this is probably without any real V-droop applied to it right now. Anyway, so that's bad. Yeah, that's bad. So the new microcode is supposed to stop this kind of behavior where the CPU just requests 1.58 volts for some reason. Actually, I do actually know what the reason is, but we're not going to get into why, because it's annoying. Like, I haven't figured out a good way to explain it yet. In like less than maybe an hour. so anyway, let's update the BIOS. I mean, I'm just gonna hit it one last time, just for fun, to see what we get. Okay, so this time we didn't get anything too ridiculous, because yeah, it's not super, like, it doesn't always happen, but it happens frequently enough that it's like breaking CPUs and stuff. So, you know, like, it's a good thing that Intel is fixing it, but I have to question why it took them like a year to figure this out, if not longer. Like, it seemed like, to me it seems kind of ridiculous that like they're patching this now when like this has been happening basically since 13th gen launch, right? Like, the voltage regulator standard since 13th gen hasn't changed. People have been degrading CPUs on like Z690 motherboards. Like, you know, and it's not like I don't think this is that difficult to test for. right? Like, you just... Like, that's the thing with this whole situation, is it really makes me question what kind of testing practices does Intel have? Because, like, did they not know that the boards do this? Like, how do they not know? Like, I know that they don't actually, like, validate their board partners' designs, but, like, the thing I'm wondering is, like, so does Intel internally for their CPU development use some unobtainium motherboard with, you know, power delivery, the likes of which the world has never seen, that just doesn't suffer from these from these issues? Because, like, this is the CPU's doing this, right? Like, admittedly, it is caused by some settings from the motherboard as well, because basically, the reason the CPU sends vid requests that high is because the CPU is, like, expecting a lot of V-droop. So if you have a motherboard that tells the CPU that, hey, there's no V-droop, the CPU won't send completely insane vid requests like that. But the thing is like, according to the Intel documentation, you're allowed to have an AC load line for desktop CPUs. You're allowed to have an AC load line as high as 1.1 milliohms. For laptop chips, it's like 2 milliohms. And the freaking V-droop prediction system just slaps a positive voltage offset onto the vid request based on the AC load line. And it's just so, like, this is expected behavior. What we're seeing here. This is working as intended as far as I'm concerned. So, like, unless, like, Intel has some other super secret internal documentation where it's like but from all the public documentation I have access to, as far as I can tell, this is just what, like, is supposed to happen. Which really makes me wonder is, like, did they not measure this? Like, how did they not notice? Like, how, like, what are they testing with? How? So now we're on the new microcode. And I've run this microcode for a little bit earlier in one of the previous takes. I don't think we're going to see anything higher than 1.54 on the oscilloscope, and Intel says this microcode is supposed to limit us to 1.55. So, yeah, but I still, like, I really don't understand how, like, how does this happen? Like, I would assume that at some point during development, they had an oscilloscope hooked up to the power delivery to monitor the voltages. And, like, unless they just didn't, in which case, like, what? Or the other option is that, like, Intel thought that this behavior was safe, which is arguably worse. Because that would indicate, because, like, the options here are, like, Intel didn't know that the CPU sends stupid vid requests, which is, like, pretty bad, because that means they never checked what the how their vid requests are behaving in the real world, or at all. Like, I don't know. I don't work at Intel. Or they did a bunch of, like, reliability and durability tests, and those tests said that it's fine to run 1.6 volts into the CPU, which is arguably worse. Because then it's like, oh no, this isn't like, oh, we had a bug in the software, which is like, yep, software gets bugs. Well, the tons of software has bugs. Ideally, your CPU microcode doesn't have bugs in it, but it's still software, so it has it'll have bugs sometimes. Actually, a lot of the time, like, there's a lot of microcode patches, right? Like, there's the non-K overclocking on Intel CPUs. That's technically a bug, right? Which Intel eventually patched. Actually, they patched that way faster than they patched any of these issues, because you tried to overclock a non-K CPU, and that's a big problem for Intel. But your CPU requests 1.6 volts randomly, not a big problem. So, anyway, also let's just check that the microcode actually applied. But yeah, so it's like buggy microcode because like nobody checked if the microcode is working correctly is like arguably less of a problem than if the microcode is was working correctly and they thought that those voltages are safe. Because that would mean that their like reliability testing is like not generating accurate data, right? Because if you're a CPU manufacturer, like one of your key jobs is to figure out what kind of operating conditions your silicon can tolerate. So if you measure the silicon to tolerate 1.6 volts, and then in the real world it starts dying on your customers, your measurement methodology is garbage, and you need to do something about that. So, like, I really hope we're looking at, like, oh, they just didn't bother to check if the microcode works for, like, 2 years, versus they thought 1.6 volts is fine. Because, like, not that either of those are particularly good. But yeah, anyway, it looks like this new microcode does do what it sets out to do. Obviously the issue is that these are like random voltage spikes, so, you know, like I don't oh, wait, what? Do I have a core count limit? Why is this running so slow? What is up with that? Did they set an even lower power limit on this new version? Are we on the like Intel default profile instead of the Intel default extreme profile? Nah, it says 253. Is CEP kicking in? Oh, we're hitting CEP. Gigabyte. Why? What did they do to the AC load line this time? Actually, maybe Intel tightened up the CEP tolerances. Because I've already checked the like default V-droop on this motherboard, and it's 1.1 milliohms on the voltage regulator, but Gigabyte was setting the load line to 0.9. So if Intel tightened up the tolerances, then yeah, that's probably... Man, here I was like, oh, this is going to be a quick and easy video. We run the fixed BIOS, things are fixed. I can go like, look, things are pretty fixed. And then, of course, no, they're not, like... Why would it ever be that simple? When it could be way more complicated. I mean, if this microcode is working as it's supposed to, then even this should be just fine. Though, it is better to run less. The thing is, like... I'll go for 100 on both. Though, as far as, like... The annoying thing is I don't have a way to actually directly... ask the voltage regulator what the load line setting is on the voltage regulator, because that's like my favorite part of Intel motherboards. There's 3 load line settings. You have the actual load line setting of the voltage regulator, and then you have the AC load line setting, which is just the motherboard telling the CPU what the voltage regulator is supposedly programmed to. And then you have the DC load line setting, which is used for like correcting the V-droop in the vid request so that the CPU gets like accurate power measurements. So the DC load line actually doesn't really matter. That one really is like, I question why that even exists. Actually, I question why AC load line exists as well, because like you could just, you know, like if Intel was sensible about this, they would just ask, like they would have just, like Intel makes a voltage regulator spec, okay? Like Intel makes the spec for the voltage regulators that get used on their motherboards, right? So if I were Intel, I would go and demand that as part of the spec, the voltage regulator tells the CPU what the load line is at boot up. And then we don't need an AC load line setting anymore. Because you can just get the correct value from the voltage regulator during startup. No, at least the microcode is blocking the excessively high vid requests. Anyway, I've like experimentally tried to determine what the like V-droop of the voltage regulator on this motherboard is, and it should be 1.1 milliohms. So technically I am still slightly undervolting the load line right now. Which might be why the score is still a little bit low. This is such a stupid implementation of oh, and it, okay. Wait, so maybe there is a power limit, and it's just like not showing up in hardware info correctly? Because it says 253. Yeah, it says 253 for both PL1 and PL2. I hate this so much. Like, I shouldn't have to be fixing this. Because, like, ultimately, right, like, the whole issue with this is, like, the end user is not supposed to have to fix this kind of thing. Like, for the end user, this is supposed to just work. And this is after they already, like, didn't, like, they just... I mean, this I blame on Gigabyte. If setting this to 1.1 milliohms fixes this behavior, then this is a Gigabyte issue. This isn't like Intel being stupid. I mean, I think it's pretty stupid that Intel gives Gigabyte the permission to do this kind of thing, but the fact that Gigabyte is dumb enough to do this kind of thing is like, you know, kind of on Gigabyte. You know who doesn't give their board partners permission to do dumb things? NVIDIA. Now, I don't like NVIDIA very much, but like, you know, when it comes to the out-of-the-box configuration, there should probably be a pretty rigid spec on what out-of-the-box configuration is. Why can't I scroll? Oh, because I have the, like, multiple... how do I collapse that? There we go. Because I wanted to see all the clocks next to each other. Yeah, so the issue... So as you raise CEP, the score will come down a bit because it basically... It's kind of like... It eats into the, like, voltage headroom, or... It's... Yeah, it, like, kind of eats into the voltage headroom that the CPU has. The other way that I could have fixed this is I could have I could have matched the, okay, wait, so this doesn't look like CEP. Unless there's some brand new bug that's like... No, this looks like CEP kicking in. Like, the clocks that the CPU is reporting are impossibly high, but the temperatures are low, voltage is high, power consumption is low, performance is terrible. So this really looks like CEP is getting triggered, but why? Like at this point, the voltage, like, it should be matched correctly. What did they do? Man, I might have to go, like, test, like, the Asus boards that I have to see if... I would imagine that Asus has at least checked that this kind of thing doesn't happen. So R23 is, like, not triggering this. Maybe. I don't know. It's weird how R15 seems to be, like, the biggest enemy of my 14900K. I mean, there's probably other workloads that would trigger this behavior, but, you know, like, that's the issue with, like, software is, like, you can't test all of the software, right? And I don't use an Intel CPU day to day, so, like, I don't know if there's, like, you know, something that I use every day that would, like, be problematic. So yeah, R23 is, like, fine, but R15 is, like, not. That is so weird. Why? So now it's working correctly, I think. Yeah. Wait, does it, like, complain about hardware info being open or something? Yeah, because right now it's working just fine. Oh, wait, no. Wait, and this is broken. What? That is so weird. I'm trying to think of, like, what else could I run that would be, like... Yeah, no, this isn't running correctly. Like, I can just tell from the voltage on the oscilloscope, it's way too high. We're in CEP. But why? Or maybe it's, like, not running on the E-cores? No, because we're seeing all the threads load up. I mean, that doesn't mean they're getting, like, that the workload's getting distributed across the cores correctly. Oh, okay, we're not on CEP, it's just being stupid. It's just being stupid. Okay, so that's not Gigabyte's fault. That's just Windows being stupid. Of course. Okay, so it's not broken. That's just, like, that like evidently running Cinebench R15 standalone is like has problems with E-cores. Cool. But either way, like in spite of all this, we haven't gone over 1.55 volts. So yeah, it looks like Intel's new microcode, uh, as far as I can tell, does what it sets out to do. Thinking if there's anything else that like, I can't really think of anything that would be particularly spiky. Because we could try Time Spy. Because that's like a pretty memory-intensive all-core workload. The CPU test. But I don't think that would be any worse than like Cinebench 15. Still confused why R15 like randomly runs on the E-cores though. I'm specifically going for the old Time Spy CPU test because this one isn't quite as multi-threaded as the extreme version. So it's more likely to hit higher voltages. Oh, I should have turned off system info. Just so that it doesn't take forever to run. Yeah, you can see some pretty high voltages there, but nothing above 1.55. So, yep. Looks like working as intended. Anyway, actually, you know what? Let's quickly throw an undervolt on this to see. Well, mostly just to see like if I can like make the performance a bit better, because like yeah, this micro, it's not really any slower than 125 was. But compared to the unsafe microcodes, or like well, 125 is also not safe, but like, okay, we're gonna go with high just because I remember that one off the top of my head correctly. So that, and then core voltage mode, adaptive, yeah, legacy's fine. And what? Oh, wait, that's internal vCore. We don't want to change that. We want the offset. I'm going to go for like minus, I don't know, 134. That should be like, yeah, that should be okay. Now it should put us back like closer to 40,000 points in Cinebench 23. Also, this configuration might have slightly lower max voltage, just because I lowered the AC load line. I think I realized why Cinebench 15 was getting put on the E-cores. I think it's when I like didn't have the window in focus. Windows took that to mean that I want it to run in the background and moved it to the eCores, is my guess. And then when you run it through Benchmate, I think Benchmate blocks that behavior. So that's why like this, or maybe, well, I don't think I pulled up hardware info at the same time. Now, obviously, if you're undervolting like this, you might potentially, you know, like cause instability by just setting the undervolt too low. But anyway, yeah, we're back up at 40,000 points. Mind you, right now, CEP is turned on. So, like, you don't need to turn CEP off in order to undervolt. Unless you're going to undervolt by intentionally setting the AC load line below the load line of the voltage regulator on the motherboard, which, like, you can do that, but I'm not sure that I don't really see the point in doing that, because, like, I understand why. Like, because if you're using, like, a flat offset like this, it offsets all voltage points the same. Right? So everything like the 6 gigahertz voltage point gets lowered by 100 millivolts. The 5 like every single frequency gets lowered by 100 millivolts, right? Whereas if you use AC load line, like if you undervolt by setting AC load line lower than VRM load line, you end up with a undervolt only at very high current output. So, like, you won't undervolt your high frequencies while undervolting your low frequencies. Which you can do, but I don't know why you'd bother with that. Especially since, like, I don't know if turning off CEP is really, like, how bad an idea that is. But, like, Intel does recommend that you keep it turned on. And after all of this, I think I would follow that advice from Intel, right? Just don't turn CEP off. And you can still undervolt using just regular vid offsets. But yeah, you can't undervolt by like intentionally setting the AC load line below VRM load line. So anyway, yeah, now our voltages are way lower because we also have that like undervolt just across the entire vid table. So, yeah, as you can see, it maxed out at like 1.4. Now, admittedly, I don't know if this minus 130 millivolt undervolt is stable, right? And depending on your CPU, it very well may not be. But, like, you know, this is the way if you want to boost the performance back up after applying the microcode update. So, yeah, anyway, that's it for the video. It's a real shame that, you know, I made an idiot out of myself with the whole Cinebench 15 and the eCores situation. Oh, well, I mean, if Intel can put out dodgy microcode updates for CPUs, I can not understand how Windows works, right? We all make mistakes. So anyway, that's it for the video. Hopefully you found it somewhat interesting and useful. And, yeah, that's it. So thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comments section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store. Actually, it's just spring now, isn't it? Anyway, it's like shirts, posters, hoodies, you know, usual YouTuber merch. And there's also a Bandcamp link if, like, you hate having functioning ears for some reason. So, yeah, anyway, that's it for the video. So thanks for watching, and goodbye.